Good morning, all the participants, and a very warm welcome to Dr. Parish Patel, sir. Dear students, this is our third lecture of symmetry and group theory in chemistry and its applications. I request Parish, sir, to proceed further. Thank you, sir.
Okay, thank you, Khushbu madam, for providing me this platform. So, good morning, all dear students. So, yesterday we discussed about the how to find out the class of any particular group. So, yesterday we discussed the one example that is the water molecule. Water molecule consists E, C2, sigma V X Z, and sigma V Y Z symmetry elements. And we know that with the help of the conjugate properties, we discussed yesterday about the E is conjugate to itself, C2 conjugate to itself, sigma V exact conjugate to itself, and sigma V y is conjugate to itself. So numbers of the classes is equal to 4 in case of the water molecule. Now today we are going for the another molecule that is known as that is the ammonia molecules. Okay, so before starting how to find out the class for the ammonia molecules, so conjugate properties. Yesterday we already discussed that A, B, C, D, X, these are the different symmetry elements of a particular group. And if first X inverse A into X is equal to A, it means A is conjugate to A itself to form an individual class. Second conjugate property, X inverse A into X is equal to B. So B is the similarity transformation of A by symmetry operation X. So A and B conjugate to each other to form a combined class. And third one, that is X inverse A into X is equal to B. X inverse B into X is equal to C. It means A, B, C conjugate to one another to form a combined class. Okay. So we have to find out which one is the appropriate conjugate properties for our representation. Yesterday we discussed about the water molecules. In case of the water molecules will fulfill the first condition. So today we are going for the another example is the ammonia molecule. Now in case of the ammonia molecule, ammonia molecule consists E C3 plus, C3 minus, sigma Va, sigma Vb, and sigma Vc symmetry elements. So in case of the ammonia molecules, number of the symmetry elements is equal to 6. Now we have to go for the conjugate properties. E inverse E into E. C3 plus inverse E into C3 plus is equal to C3 minus inverse E into C3 minus. Sigma Va inverse E into sigma Va. Sigma Vb inverse E into sigma Vb. Sigma Vc E into sigma Vc is equal to. Now in case of ammonia molecule, okay, E into E, we already discussed that if we operate identity symmetry operations, so there is no change in the position of the molecule. Now C3 plus inverse E into C3 plus. So what will happen over here? So let us see the ammonia molecule. Suppose this one is the 1, 2, and 3. So first one is C3 plus inverse. C3 plus, it means one time clockwise rotation around 120. C3 plus, it means one time clockwise rotation. So C3 plus inverse, it means one time anti-clockwise rotation. So anti-clockwise rotation. So what will happen over here? 1, 3, and 2. Again, identity. So by operating identity symmetry operation, so there is no change in the position of the hydrogens. Again, C3 plus to give 1, 2, 3. It means again answer will be the identity. Similarly, if you go for the C3 minus inverse, C3 minus inverse, it means one time anticlockwise rotation. C3 minus means one time anticlockwise rotation. And C3 minus inverse, it means one time clockwise rotation. So remember that, dear students, C3 minus, it means one time anticlockwise rotation. And C3 minus inverse, it means one time clockwise rotation. So in case of the ammonium molecules, so if you go for the C3 minus inverse, it means one time clockwise rotation. So 1, 2, and 3. Then identity. So 1, 2, and 3. Again C3 plus, C3 minus. So what will happen? 1, 2, and 3. So again identity. Okay. So in case of ammonium molecules, if we operate C3 minus E into C3 minus is equal to E. Similarly, if we go for the sigma VA inverse, so sigma VA inverse, sigma VA, it means we have to put a mirror over here. Suppose this one is the 1, 2, and 3. Sigma VA, it means we have to put a mirror over here. So what will be the result? So there is no change in the position of the hydrogen 1. So hydrogen 3 and 2 will interchange. So what will happen? So sigma VA inverse. So sigma 1, hydrogen position of the hydrogen 1 remains as it is. 3 and 2 are interchanged. Again identity means 3 and 2. Again sigma VA. So what will happen? So again 2 and 3. So original position. So overall result is identity. So overall result is identity. Again identity. So in case of the ammonium molecule, so first symmetry element is identity conjugate to itself to form an individual class. In case of the uh, E inverse E into is equal to E. C3 plus inverse into E into C3 plus is equal to identity. C3 minus inverse into E into C3 minus is equal to identity. Sigma VA inverse E into sigma VA is equal to identity. Sigma VB inverse E into sigma VB is equal to identity. Sigma VC E into sigma VC is equal to sigma VC inverse into E sigma VC is equal to identity. So this result suggests that the E is conjugate to itself to form an individual class. So okay, so for any representation, identity should be conjugate to itself to form an individual class in every each and every character table. So first class of the ammonium molecule is identity. Now second one is C3 plus. In case of the C3 plus, E inverse C3 plus E. C3 plus inverse C3 plus C3 plus. C3 minus inverse C3 plus C3 minus. Sigma VA inverse C3 plus sigma V. Sigma VB inverse C3 plus sigma VB. Sigma VC inverse C3 plus sigma VC. Now what will be the result? So if we operate different symmetry operation, suppose this one is 1, 2, and 3. So first one is E inverse. So if you operate identity symmetry operation on a ammonium molecule, so there is no change in the position of the hydrogens. So 3, 2, and 1. Again C3 plus. C3 plus, it means one time clockwise rotation. So 1, 2 and 3. Sorry, just C3 plus, again C3 plus. That means identity. So N, hydrogen, hydrogen, 1, 2 and 3. So overall result is C3 plus. Similarly, if you go for this C3 minus inverse, sorry, C3 minus, C3 minus inverse, sorry, C3 plus inverse, C3 plus inverse, it means C3 plus means one time clockwise rotation, and C3 minus inverse, it means one time anti-clockwise rotation. So what will happen over here? So C3 plus inverse, it means one time clockwise rotation. It means we have to go for the 1, 2 and 3. So this is the C3 minus. Then C3 plus, it means 1, 2 and 3. Again C3 plus, it means 1, 2 and 3. So overall result is C3 plus. So overall result is C3 plus. So we can say this is C3 plus. So C3 minus inverse, then C3 plus, then C3 minus. Now what will be the product? So C3 minus, it means one time anti-clockwise rotation, and C3 minus inverse, it means one time clockwise rotation. So if we go for the clockwise rotation, 1, 2 and 3, that will be the answer. Again C3 plus, it means 1, 2 and 3, and C3 minus. So overall result, so one time anti-clockwise rotation. So 1, 2, 3. So overall result is C3 plus. Next one is the sigma VA inverse C3 plus and sigma VA. So sigma VA inverse. Now what is sigma VA? We have to put a mirror on sigma 1, hydrogen 1. So there is no change in the position of the hydrogen 1. Hydrogen 2 and 3 will be the interchange. So if we operate sigma VA, so sigma VA inverse, that will be the same. So hydrogen 1 remains as it is. 3 and 2 are interchange. Then C3 plus. Okay, so we have to go for the one time clockwise rotation. So 1, 2 and 3. Then sigma VA. Now in case of the ammonia molecule, we have to remember that first rotation followed by the reflection symmetry operation. In case of ammonia molecule, we have to remember that rotation followed by the reflection. Then we have to observe the position of the hydrogen before rotation symmetry operation. Okay, so just like this one, this is the rotation followed by the reflection. It means we have to go for the sigma VA. So actually what will happen? We have to go for the before rotational symmetry operations position. So this is the uh, position of this hydrogen before rotational axis. Sigma VA. It means this is the position for the sigma VA. This is the position for the sigma VA. So we have to put a mirror over here. Mirror over here. Okay. એમોનિયા મોલેક્યુલ્સની અંદર આપણે એક યાદ રાખવાનું છે કે રોટેશન કર્યા પછી રિફ્લેક્શન કરવાનું હોય તો રોટેશન પહેલાની હાઇડ્રોજનની પરિસ્થિતિ જોવાની, એટલે સિગ્મા વીએ છે, સિગ્મા વીએ ની સિચ્યુએશન શું છે તો કે આઈ છે. સો we have to consider this hydrogen for sigma Va. So this is the exact position for this sigma Va. So position 3 remains as it is, and to change the position of the hydrogen 1 and 2. Now compare this and this. So this is nothing but the C3 minus. This is nothing but the C3 minus. Next one is sigma Vb minus. Sorry, sigma Vb inverse. Sigma C3 plus and sigma Vb. So see, if we operate sigma Vb symmetry operation on the ammonia molecule, position of the hydrogen remains as it is, there is no change, and 3 and 1 are interchanged. Now if we operate C3 plus, then what will happen? 1, 2 and 3. Now this is the rotation followed by the reflections. If we operate sigma Vb, then we have to consider the before position of the rotational axis. Okay, so sigma Vb, it means which corresponds to hydrogen 2. So we have to put a mirror actually over here. So we have to consider this plane for this symmetry operation. So hydrogen 1 remains as it is, and 3 and 2 are interchanged. So this is nothing but the C3 minus. And finally, sigma Vc inverse C3 plus sigma sigma Vc inverse C3 plus and sigma Vc. Now if we operate sigma Vc inverse, it means we have to put a mirror over here. So position of the hydrogen 3 remains as it is. There is no change, and to change the position of the hydrogen 1 and 2, then C3 plus, it means 1, 3 and 2. 1, 2, 3. Now this is the rotation followed by the reflection. So we have to operate sigma Vc. Then we have to consider this is the sigma Vc. So we have to put a mirror over here. So the position of the hydrogen 2 remains as it is. 3 and 1 are interchanged. So overall result is C3 minus. Okay. So if we operate C3 plus symmetry operation, so overall result is C3 plus or C3 minus. This indicates that C3 plus and C3 minus conjugate to each other to form a combined class. Okay, so in case of the ammonia molecule, C3 plus and C3 minus conjugate to each other to form a combined class. Okay, and this satisfies the condition number second, x inverse A into x is equal to B. It means A and B conjugate to each other to form a combined class. Similarly, C3 plus and C3 minus conjugate to each other to form a combined class. So in case of the second class of the ammonia molecule is 2C3. Now similarly, if you go for the C3 minus, C3 minus, C3 minus, C3 minus, C3 minus. Okay. E inverse C3 minus into E, that is C3 minus. We already know. C3 plus inverse, it means one time anticlockwise rotation, again anticlockwise rotation, and one time clockwise rotation. So answer is one time anticlockwise rotation. C3 minus inverse, it means one time clockwise rotation, anticlockwise rotation, and again anticlockwise rotation. So overall result is C3 minus. Now C3 minus inverse, sigma Va inverse, hydrogen 1, 2 and 3. If we operate sigma Va inverse, then what will happen? Sigma Va inverse, it means we have to put a mirror over here. So position of the hydrogen 1 remains as it is. There is no change. Sigma Va and sigma Va inverse both are the same. 3 and 2 are interchanged. Then C3 plus, C3 minus. Then what will happen? One time anticlockwise rotation. One time anticlockwise rotation means 1, 2, and 3. Then sigma Va. So this is again the condition of rotational followed by the reflection. So we have to, before operating the sigma Va, we have to consider the position of the hydrogens one before rotational axis. So this is the uh, position of the hydrogen one. So we have to put a mirror over here. So hydrogen 2 remains as it is, and to change the position of the 1 and 3. So this is nothing but this is C3 plus, one time clockwise rotation. So this is C3 plus. Okay. Similarly, if we operate, sigma will be inverse. The result will be the C3 plus. Here also C3 plus. So overall results for the operating by operating C3 minus symmetry operations. So C3 plus or C3 minus. We already discussed that C3 plus and C3 minus conjugate to each other to form a combined class. So anyhow, the second class for the ammonia molecule is 2C3. Next one for the sigma Va. 1, 2, and 3. See the E inverse sigma Va E answer will be the sigma V. Now first one is C3 plus inverse. C3 plus inverse, it means one time anti-clockwise rotation. Why? C3 plus it means one time clockwise rotation. It means C3 minus C3 plus inverse results into one time anti-clockwise rotation. C3 one time anti-clockwise rotation. It means one, sorry, one, 2, and 3. This is the one time anti-clockwise rotation. Next, sigma V. This is rotation followed by the reflections. It means before operating sigma Va, we have to consider the position number hydrogen 1. Okay, so we have to put a mirror over here. So, so position of the hydrogen 3 remains as it is. There is no change, and to change the position of the hydrogen 1 and 2. Again, C3 plus. Again C3 plus. It means 1, 2, and 3. Now compare this and this. Compare this and this. So this is nothing but the sigma Vc. C3 minus inverse sigma Va C3 minus. So for C3 minus inverse, it means one time clockwise rotation. So 1, 3, and 2. 1, 2, and 3. One time clockwise rotation, it means 1. Okay, this is the one time clockwise rotation. Then if we operate sigma Va, so this is rotation followed by the reflection. It means hydrogen 1. So this is the position of the hydrogen 1. So hydrogen 2 remains as it is. 1 and 3 are interchanged. Then C3 minus, it means one time clockwise rotation. So 2, 1 and 3. Now compare this and this. So this is nothing but the hydrogen 2 remains as it is. 1 and 3 interchange. So this is nothing but the sigma V. Okay, so here we operate sigma VA inverse, sigma VA, sigma VA. Answer will be the sigma VA. Next, sigma VB inverse, sigma VA, sigma VB. Answer is sigma VB. If we operate sigma VC inverse, sigma VA, sigma VC, so answer is sigma VC. So overall result, sigma VA or sigma VB or sigma VC. This means sigma VA, sigma VB, sigma VC conjugate to one and to form a combined class. So in case of the ammonia molecule, the third class is the sigma VA, sigma VB, sigma VC as a 3 sigma V. Similarly, if you go for the sigma VB, then what will be the result? So here answer is sigma VB. So here C3 plus inverse sigma VB and C3 plus. Suppose this one is 1, 2 and 3. If you operate C3 plus inverse, it means one time anticlockwise rotation. So 1, 3 and 2. Then sigma VB. This is rotation followed by the reflection. It means sigma VB. So this is the exit position for the hydrogen 2. So we have to consider this hydrogen 1 as it is. 2 and 3 are interchanged. Again C3 plus. C3 plus, it means 1, 3 and 2. Now compare this and this. This is nothing but this sigma VA. So it should be sigma VC, sigma VA, sigma VB, and sigma VC. Okay. So overall results sigma VA or sigma VB or sigma VC. So this indicates that sigma VA, sigma VB, sigma VC conjugate to each other to form a combined class. And last one, if we take sigma VC, sigma VC, C3 plus inverse. C3 plus inverse, it means one time anticlockwise rotation. So 1, 2 and 3. Then we have to operate sigma VC. Sigma VC, which corresponds to hydrogen 3. This is again rotation followed by the reflection. It means we have to put a mirror over here. So the position of the hydrogen 2 remains as it is. 1 and 3 are interchanged. And again C3 plus, that means 1, 2 and 3. Now compare this and this. So there is no change in the position of the hydrogens. It means this is sigma VB. So similarly, we can apply for sigma VA, sigma VA, sorry, it should be sigma VC, sigma VC, sigma VA inverse, sigma VC is equal to sigma VC, again sigma VC. So overall result is sigma VA, sigma VB, sigma VC. So thus the third class of the ammonia molecule is 3 sigma V. So this can fulfill the condition number 3. So with the help of conjugate property, we can assign a class of a particular representation. So in case of the ammonia molecule, numbers of the classes is equal to 3. Ammonia molecule consists 6 symmetry elements, but numbers of the classes is equal to 3. E is conjugate to itself to form an individual class. C3 plus and C3 minus conjugate to each other to form a combined class. And sigma VA, sigma VB, sigma VC conjugate to one another to form a combined class. So this is the uh, similarity transformation, or we can say this is the how to find out the class of any representations. Now we are going for the another title of our unit, and this is the most important title for our syllabus. So name of the title is matrix representations for the different symmetry operations. It means how to find out the matrix for the different symmetry operation for a particular group. This can also represent it as a geometrical transformations. Geometrical transformations or matrix representations of different symmetry operations. Uh, First symmetry operation is identity. Second one is the proper axis of rotation, and that can be carried out either in clockwise rotation or anti-clockwise rotation. Third one is a reflection. Fourth one is improper axis of symmetry, and fifth one is center of symmetry, or we can say point of symmetry. So dear students, this is the most important title for your MCQ questions, because exam point of view, you may be asked for the uh, matrix representations for C3 plus, matrix representation for C3 minus, matrix representation for sigma VA. So how to derive the matrix, that is most important for you. So first one is identity. We already discussed that if we operate identity symmetry operation on molecule, so there is no change in the position of the molecule. So we can represent this symmetry operation on x-axis. A into x is equal to 1 into x plus 0 into y plus 0 into z. A into y is equal to 0 into x plus 1 into y plus 0 into z. A into z, 0 into x plus 0 into y plus 1 into z. Okay, so along the x-axis, the situation is unique. Along the y-axis, this is the unit, and along the z-axis, this is the unit. So E into x, y, z is equal to 1 0 0 0 1 0 0 0 1, and x, y, and z. Okay, so E is equal to 1 0 0 0 1 0 0 0 1. Okay, so this is the matrix representations for identity symmetry operations. Okay, and this is the derivation how to derive the matrix representation for the identity symmetry operation. So whenever you may ask the questions for the identity matrix representation for the identity symmetry operation, it is this part to 1 1 0 0 0 1 0 and 0 0 1. Second one is rotation. Rotational axis of symmetry. Now rotational axis of symmetry, we know that if we rotate any molecules around theta to get the equivalent orientation position, but this rotation can be carried out either in clockwise or anti-clockwise. Dear students, આપણે મોલેક્યુલ્સને ક્લોકવાઇઝ પણ ફરાવીએ અને એન્ટી ક્લોકવાઇઝ માટે પણ ફરાવીએ. બંનેના માટે આપણે મેટ્રિક્સ ડિરાઈવ કરવાનું છે. તો બંનેના માટેનો મેટ્રિક્સ ડિફરન્ટ હોઈ શકે. નાઉ ફર્સ્ટ વન ઇઝ ફોર એન્ટી ક્લોકવાઇઝ રોટેશન. Now, this is the vector P with the coordinates x and y. It means along the x-axis the distance is x, and along the y-axis the distance is y. Okay, the vector P with the length of this vector is r. Now, the angle along the x-axis is phi. Now, this is right angle. This is right angle. So we can say that cos phi is equal to base divided by hypotenuse. So what is the base? So x divided by hypotenuse means r. Hypotenuse, this is the length of the vector r is equal to vector p is equal to r. So x is equal to r cos phi. Sin phi is equal to front side divided by hypotenuse. So front side is nothing but the y. So y by r. So y is equal to r sin phi. Okay. Now this is the initial position of this vector p. Now if we operate this vector p to p dash, that is anti-clockwise rotation, then what will happen? Now if we rotate vector p around theta about anti-clockwise rotation to give a new position p dash, and with the coordinates x dash and y dash, it means this is the shifted position. Along the x-axis is x dash and along the y-axis is y dash. So we can represent it as cos phi plus theta is equal to base divided by hypotenuse. The value for base is equal to x dash, and hypotenuse, it means r. So x dash is equal to r cos phi plus theta. Similarly, sin phi plus theta is equal to front side. Front side is y dash and hypotenuse is r. So y dash is equal to r sin phi plus theta. We know that cos a plus b is equal to cos a cos b minus sin a sin b. Now substitute this value. So x inverse is equal to r cos phi cos theta minus sin phi sin theta is equal to r cos phi cos theta minus r sin phi sin theta. But we know that the value for r cos phi is equal to x, and r sin phi is equal to y. This is x and this is y. So we can write over here x cos theta minus y sin theta. This is about x test. So this is the one equation. Similarly, if we go for the sin phi plus theta, we know that sin a plus b is equal to sin A sin B plus, sorry, sin A cos B plus sin B cos A. So we can apply to this one. So y dash is equal to r sin phi cos theta plus r cos phi sin theta is equal to, we know that this is the value r sin phi is equal to y, and x cos theta is equal to x. So x cos theta plus x sin theta. Now anyhow, y dash is equal to x sin theta plus y cos theta. So these are the two equations. Now we can represent this equation. We can represent these two equations in form of the matrix x dash y dash is equal to cos theta minus sin theta sin theta cos theta x and y. Now we can write these equations in form of the matrix just like this one. So this is P dash and this is C and K anti-clockwise and P. So where C and K anti-clockwise rotations cos theta minus sin theta sin theta cos theta. Now this is a two-dimensional system. We can extend it up to three-dimensional system. So C and K anti-clockwise is equal to cos theta minus sin theta 0 sin theta cos theta 0 0 0 1. So this is the three-dimensional system, and this is the matrix representations for anti-clockwise rotation. So if we put a value of theta is equal to that rotations to give the matrix for that representations. If we operate C2 symmetry operation for anti-clockwise rotation, it means C2 inverse. So theta is equal to 180 to give the resultant matrix, that is for the C2 inverse. Okay, so dear students, આજે આપણે મેટ્રિક્સ આજે આપણે ઇક્વેશન ડિરાઈવ કર્યું છે, એ ઇક્વેશન્સ આપણે એન્ટી ક્લોકવાઇઝ ના રોટેશન માટેનું છે. એટલે આપણે કોઈ પણ એન્ટી ક્લોકવાઇઝ રોટેશન કરવું હોય તો આ ઇક્વેશનથી આપણે કરી શકીએ એમ છે. So this is the equations and we have to remember that, as for example, if you go for the C2 inverse, okay, value for C2 inverse, so we have to put a value cos 180 sin 180 1 sin 180 cos 180 0 0 0 1. So is equal to cos 1 minus 1 0 0 0 minus 1 0 0 0 1. So this is the matrix representations for C2 minus C2 inverse or C21 inverse. So dear students, this is the matrix representation for anti-clockwise rotation, and we have to remember these equations to get the matrix representations for anti-clockwise rotation. next title is the matrix representations for clockwise rotation. આપણે એન્ટી ક્લોકવાઇઝ માટેનું મેટ્રિક્સ મળી ગયું. હવે આપણે ક્લોકવાઇઝ રોટેશન માટે. Now this is the matrix P with the coordinates x and y. Now the angle along the x-axis is phi. The length of this vector is r. Pxy, it means along the x-axis the distance is x, and along the y-axis the distance is y. Now cos phi, we already discussed that, is equal to base divided by hypotenuse. It means x by r. So x is equal to r cos phi. Similarly, sin phi is equal to y by r. So y is equal to r sin phi. Okay. Now this is the initial position of this vector p. Now if we operate vector p around theta, that is about clockwise rotation. So what will happen over here? Suppose this one is p dash, x dash, y dash. So along the x-axis, the distance is x dash, and along the y-axis, the distance is y dash. This is theta. It means overall result phi minus theta. This is phi minus theta. This is clockwise rotation. So P becomes P dash, and the angle should be phi minus theta. આપણી પાસે વેક્ટર P છે અને ક્લોકવાઇઝ રોટેશન કરાવે તો P dash. આપણી પાસે ઇનિશિયલ એંગલ કેટલો હતો? phi હતો. પછી આપણે θ રોટેટ કર્યું. It means this angle should be phi minus theta. So cos phi minus theta is equal to base x dash by r. Similarly, sin phi minus theta is equal to y dash by r. So simplify this equation. Cos a minus b is equal to cos a cos b plus sin a sin b. Cos a minus b is equal to cos a cos b plus sin a sin b. So cos x this is equal to r cos phi minus theta. Y this is equal to r sin phi minus theta is equal to r cos phi cos theta minus r sin plus r sin phi and sin. Now we do that the values of r cos phi and r sin phi is equal to x cos theta plus y sin theta. This is from x. Now if we go for the simplification of this y dash, so y dash is equal to r sin a minus b is equal to sin a cos b minus cos a sin b. So y this is equal to r sin phi cos theta minus r cos phi sin theta. This is the value for x, and this is the value y, and this is the value for x. So y this is equal to y cos theta minus x sin theta, or we can write it as y this is equal to minus x sin theta plus y cos theta. So this is the equation for y dash. Now x is equal to x cos theta plus y sin theta, and y dash is equal to minus x sin theta plus cos theta. Now we can represent these two equations in form of the matrix. X dash and y dash is equal to cos theta sin theta minus sin theta cos theta x and y. X dash and y dash cos theta sin theta minus sin theta cos theta. So this is P dash and this is C and K clockwise rotation, and this is P, where C and K clockwise is equal to cos theta sin theta 0, sorry, sin theta minus sin theta cos theta. Now this is two-dimensional system. We can extend it up to three-dimensional system. So C and K clockwise rotation is equal to cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. So this is the matrix representations for clockwise rotations. So dear students, we have to remember that this is the matrix representations for clockwise rotation. આપણે કોઈ પણ મેટ્રિક્સ મેળવવું હોય clockwise માટે, so if we put a value for theta to get the matrix for that presentation, that representation. Okay. Now in case of the water molecule, if you operate C2 symmetry operation, okay, and C2 inverse symmetry operation, so answer will be the same. Why? In case of the water molecule, if you operate C2 symmetry operation to change the position of hydrogen 1 and 2, and in case of the anti-clockwise rotation, so there will be the same results. Hydrogen 1 and 2 are interchanged. So in that case, if we put a value is equal theta is equal to 180, so we have to give the same matrix for either in the clockwise or anti-clockwise. So okay, so this is the clockwise rotation. So if we go for the theta is equal to 180, so cos 180 sin 180 0 minus sin 180 cos 180 0 0 0 1. So this is the, okay, we know that 1 0 0 1 minus 1 0 0 and minus 1. Here cos 0 is equal to 1, sin 0 is equal to 0, cos 90 is equal to 0, sin 90 is equal to 1, cos 180 is equal to minus 1, sin 180 is equal to 0. This is the value for uh, cos, and this is the value for sin. So anyhow, uh, cos 1 is equal to, cos 180 is equal to C2 1. Cos 180 is equal to minus 1. Sin 180 is equal to 0. Again 0. Sin 180 is 0. Cos 180 minus 1. 0. 0, 0, 1. So this is the matrix representations for clockwise rotation. We already derived the matrix representations for C2 inverse. That is also 1, 0, 0. 0 minus 1, 0. 0, 0, 1. So in case of water molecule, if you rotate either clockwise or anti-clockwise, answer will be the same. So this is the matrix representation for C2. Okay, so dear students, these are the two matrix representations, that is for anti-clockwise and clockwise rotation, and we have to remember the equation for both these matrices. So now next title is the matrix representations for reflection symmetry operation. So third symmetry operation is reflection. Now in case of the reflection, what will happen if we have to image a mirror, and with the help of that mirror we can we can bisect the molecule in such a way that one part is the mirror image of the another part of the molecules. Suppose vector p with the coordinates x and y. This is the x-axis and this is the y-axis. Vector p with the coordinates x and y. If we reflect this vector p with the help of this mirror sigma v yz to get the resultant vector p dash. Okay, with coordinates x dash and y dash. Now, if we write the position of x and y, position of this vector p to p dash along the x-axis and along the y-axis. What is the situation? X dash is equal to. So here what will happen if we reflect this vector p through this y-z plane? So p becomes p dash. It means this x becomes minus x. P becomes x becomes minus x. So we can represent this x. This is equal to minus 1 into x plus 0 into y. So there is no change in the position of the along the y-axis. So y dash is equal to 0 into x plus 1 into y. So there is no change in the position of the along the y-axis. Y remains as it is by reflection through yz. તમે વેક્ટર p ને રિફ્લેક્ટ કરો તો x નો માઈનસ x થશે પણ y એની હાઈટમાં કોઈ ફેરફાર થવાનો નથી મીન્સ y remains as it is. So 0 into x plus 1 into y. So x dash y dash is equal to minus 1 0 0 into 1, and x and y remains as it is. So here sigma vyz is equal to minus 1 0 0 into 1. This is p dash, this is sigma v yz, and this is p. Okay, now we can extend it up. This is two-dimensional matrix. We can extend it up to three-dimensional matrix. We can extend it up to three-dimensional matrix. Sigma v yz is equal to minus 1 0 0 1 is equal to minus 1 0 0 0 1 0 0 0 1. So this is the matrix representations for sigma v yz symmetry operations. Similarly, we can derive for sigma v xz is equal to 1 0 0 0 minus 1 0 0 0 1. And similarly for sigma v xy is equal to 1 0 0 0 minus 0 1 0 0 0 minus 1. Okay, so these are the this is the third symmetry operation, matrix representations for reflection axis of symmetry or reflection plane of symmetry. These are the three matrix for the uh, plane of symmetry. Now, in case of this sigma h, we have to remember that sigma h is a horizontal plane and horizontal plane through z. It means sigma h is nothing but the sigma xy plane. So, whenever we talk about the sigma h, it is nothing but the sigma xy plane. So, sigma xy plane. So, matrix representation for sigma h is equal to 1 0 0 0 1 0 and 0 0 minus 1. So, dear students, today we already discussed the how to find out the class for ammonium molecule and matrix representations for identity symmetry operation, then proper axis of symmetry, that is for anticlockwise and then clockwise rotation, and lastly we discuss about the how to derive the matrix representations for sigma vxy, sigma vyz, and sigma vxz, as well as for sigma h. So I think this is the enough for today's discussion. So dear students, we will meet in the next lecture. So thank you very much for listening me very silently, and also to Kushbu madam for providing me this platform to discuss with our students. Thank you very much, Kushbu madam also. Hello. So I think this is the end of today's discussion. We will meet on the next lectures. Thank you very much.
Thank you,
Hello.
sir. Thank you very much.
Yes, yes, yes.
Thank you, Paresh,
Okay.
sir. It was a very interesting lecture today, and we all are very grateful for providing your valuable time to the students. Thank you very much, sir.
Okay.
Bye,
Goodbye.
everyone. Stay safe, stay healthy.